Hello, today we're going to talk about galaxies in a lecture that I call A Universe of Galactic Islands. Now, the galaxies are in the universe very spread out, almost like tiny little islands that are so far apart you could barely see the next one over. And in fact, we'll find that's the case. A lot of the dimmest lights in the night sky that we can't even see with our eyes, but we can see with a really good telescope, those are just the closest galaxies. We have to use truly advanced technology to find galaxies that are beyond just those faint little dots of light. In fact, we'll explore some of the different types of galaxies and how we know what we know about them. So let's dive right in. Let's take a look at, starting with what you know about galaxies. Can you name our galaxy? What's our galaxy called? Why is it called that? That's a strange name for a galaxy. The Milky Way. When the ancient Greeks looked at the night sky, they saw this splash of faded light across a really clear, dark sky. And it looked like someone had splashed some milk up in the night sky and it stayed there. The way of milk. Ironically, the word Galaxias means the way of milk. So we say the Milky Way galaxy. Really, we're saying the galaxy, the way of milk twice. So it was only until recently we realized what we were looking at is actually a turning spiral mass of 100 billion stars. No, wait, 100 million stars, million with an M. 100 million stars all orbiting a very densely packed, crowded, bright, glowing center, and a supermassive black hole anchoring it all together as this entire group of stars travels through space. Very cool stuff. Now, if you can name any other galaxies, I'm going to share a few with you today, especially if you think of the galaxy next door, Andromeda. We'll talk a little bit about that today and a little bit in our next lesson that follows this one. Let's take a look. All right. So when I say Hubble's vision, Edwin Hubble spent his life fascinated by the night sky. He had the very best telescopes of the time. This is not quite 100 years ago, but he would look and see things in the sky and find their meaning far better than a lot of other people could. He looked at this fuzzy little patch in the Andromeda constellation, right? That address in the sky, the Andromeda constellation. And he realized, I'm not just looking at a little patch of clouds among some stars. It's much further away. It's in fact a gathering of stars completely separate from our own galaxy. And when he could mathematically prove it, it blew everyone's mind. We had no idea that the universe was so staggeringly immense. So let's talk about what Hubble showed us with his research. Not just that the universe is filled with galaxies. By the way, this is not a composite of 18 different pictures all mushed together. This is one picture of a cluster, a supercluster of galaxies all gathered together in the same image from deep in the universe before they had a chance to really spread out and distance themselves from one another. So, Hubble noticed these galaxies far away, and when he finally realized what he was looking at, he started noticing patterns. Okay, and he came with a way to classify the different types of galaxies he could see. He noticed some of them are roundish, like a basketball or a football, right? Others have beautiful symmetry. They look like a frisbee shape, right? Flat, and like a disc, and they have these spiral, like almost a whirlpool effect to them. And then I noticed other spirals had a bar running through the middle with arms coming off of it. A little less like a whirlpool, more like one of those spinning firecrackers on the 4th of July that shoots off in a couple directions, but there's a bar that's spinning in the middle. So he classified them: ellipticals, spirals, and then the ones that kind of ignore his attempt to classify them. We'll talk about the irregulars as well. Let's go through them a little bit when we consider what they look like and how they move. That's where they are different. The spiral galaxies, like our own, are shaped like a disc. They have rotation. They appear to be reasonably symmetrical as they spin in a circle. The Milky Way is a barred spiral, and it's making stars, new stars, in those spiral arms all the time. Very good at building new stars is a spiral galaxy. He also noticed the ones that were rounded and sometimes a little stretched, like a rugby ball or a football. Okay, these are the ellipticals, because if you were to draw the circle, it looks like an ellipse around the edge of it, kind of an oval shaped. And he noticed they were also three-dimensional, and they were kind of reddish. They looked, and he realized, it was actually proven later, that they're made of older stars. Ellipticals are not producing brand new stars all the time as much as the spirals are producing new stars. Okay, so that's interesting and fascinating. The irregulars are the galaxies that really don't match any patterns, and they don't cooperate with Edwin Hubble's attempt to categorize. They are twisted and stretched. They're in odd shapes, usually because they're in the process of two galaxies colliding together and pulling each other into funny shapes. I'm going to show you some of these things and what they look like. Check it out. So the spirals, symmetry, beautiful. If you were this view of a spiral galaxy up close, it would bring a tear to your eye. They are so beautiful the way they are. Take a look at Sombrero Galaxy. There's another neat one. And I've actually seen this one. I've been fortunate enough to see the Sombrero through a telescope, and it just stops you. It's so beautiful, you just can't even form the words. It is this beautiful. Other spirals, faint and ghost-like, they have a glow about them. And then we come to a different kind of spiral that has this bar of stars running through the middle, bright bar through the middle. Sometimes they have 2 arms, sometimes they have many arms. And if you look at this one, the Whirlpool Galaxy, this is the one that we believe that the Milky Way galaxy looks something like this. There's a very exaggerated bar spiral, beautiful. Look at the bright lights in the middle as they swirl around that anchoring supermassive black hole in the middle. Check it out. And as we consider the older and larger galaxies, the ellipticals, these are the granddaddies of the universe. This is M87, Messier 87. And if you remember that picture of the black hole that they managed to take last year, this is the galaxy where that black hole lives, the one they took a picture of. It's 1,000 light years away, and it is a huge, old stars, lots of stars, maybe 1 billion stars in this galaxy. That's a lot. Check it out. Other ellipticals can appear really fuzzy around the edges and stretched. Others just appear more rounded, more like a sphere, okay, in space. But if we consider the size and scope, take a look at how big the ellipticals can get. Here's our Milky Way over on the left. Okay, beautiful barred spiral. Andromeda Galaxy is about twice the size, so still pretty. These are considered large galaxies. And then you see M87, the one where the black hole picture was taken. And then you see IC 1101. I see 1101. Look at the size difference in these galaxies compared to our own Milky Way. Check that out. It's incredible. And there is a third category of galaxies, the irregulars. And these are the ones that don't follow patterns. These are ones that are the most strange and beautiful of all the galaxies. I'm going to show you a few of those so you get an idea. Now, we think a lot of these irregular galaxies are two galaxies or more in the process of colliding and becoming a larger galaxy as they grow together. Check it out. Look at the mouse galaxies. Some people see a hooded figure holding a sword, or maybe it's a Jedi holding a lightsaber. Other people see the Nike swoosh in this one. Other people see the two galaxies like chasing around each other like two little mice, giving this particular irregular galaxy its name, the mouse galaxies. This one's my favorite. These are the antennae galaxies, like the antenna on a car. So the antennae galaxies, you can see one spiral over here and the arms coming off of it, and you see the other spiral over here, the arms are coming off of it. And in the middle is where they're being stretched and pulled together by their mutual gravity to form this breathtaking, beautiful, irregular galaxy. All right, let's consider the pages you're going to be building in your book. Previous lecture, previous video talked about how to build up to, let's see, this is page 35, where we're thinking beyond our solar system now. And then page 36 and 37, you're choosing a constellation, telling a story, and explaining how constellations are like addresses in the night sky. Let's move forward into stellar nurseries and nebulae, clouds in space. That video is also available to you here. And then we have what we talked about today, the galaxies. On page 40, I would like you to show Hubble's tuning fork. Okay, sketch it as it is, make sure it has all the labels. Don't forget to include the irregulars. They're out there as well. And since they don't belong on the pattern of the fork itself, you can include them, off to the side there. And then, what are galaxies? And where the word comes from, and Hubble's discoveries. Take some things I've talked about in this video, or do research of your own. And fill in. Give it a full page on page 41 about what galaxies are in general. Looking at 42, I'm going to have you sketch our Milky Way galaxy and show what we believe, what we've mathematically predicted that it looks like. We don't actually have a photo of our Milky Way, right? But the galaxy mapping its stars, we strongly believe, is a barred spiral, and it looks like this. We even know roughly where we are in the galaxy, about 2/3 the way out of from the center to the edge of the disk. So do your top view, do your side view on page 42, and add all those labels, those numbers, sun's location. Make sure you include those in your sketch. Page 43, spiral galaxies, barred spiral galaxies. Describe them in terms of how they move. They spin and they move through space. They tumble as they go. And answer some of those other questions. Fill up page 43. Page 44 looks like this, where you describe some of the elliptical galaxies, the largest and oldest of all the galaxies in the universe, and then the irregular galaxies. You'll describe them on page 45. The picture you draw on page 44 is entirely up to you. I would have chosen my favorite, the antenna galaxies. Pick the one you like. You can draw an elliptical. You can draw an irregular of your choice. Look up, just Google search some images, or go to your references on page 4, find some that you like, and go ahead and just capture one of them. Please don't just draw a circle and an oval shape and call it an elliptical galaxy. Make it look like a galaxy. Okay, all those little dots and shading colors, and the shape and the swirl of the stars. Give it some life. Okay, and that will take you out to page 45. We're almost done at this point with chapter 2. Don't forget your due date is coming soon, so make sure and get these done as quickly as you can. Take those pictures, submit them, or when we're back in school again, when I see you in class, show me your notebook and I'll give you your grades. Okay? So that captures our discussion of galaxies today. Remember the types of galaxies, what Edwin Hubble noticed about the galaxies, and what that did for our perception of how big the universe really is. Staggeringly immense. And all these galactic islands scattered throughout. Breathtakingly beautiful. Let it inspire you as you build chapter 2. And let me know if you have questions. Thanks for watching.